the first section in portfolio optimization or on portfolio optimization. And what we're going to think about here is the minimum variance portfolio. But the the main thing we do when we optimize a portfolio, it depends on a couple things. So it depends on how much risk a person's willing to tolerate or what return they're trying to target. And what we'll see throughout this section on optimization is you can choose one or the other. If you choose one, you're stuck with the other. So if you want a high risk, if you're willing to if you want a high return, you're probably going to have to accept more risk. If you want a lower variance, you're probably going to have to accept a lower return. So this is going to walk us through how portfolio optimization works. And again, this is portfolio optimization. So we're choosing a bundle of stocks and then weighting those accordingly, and then weighting those to achieve the goals we're trying to meet. So we're not picking a particular stock. Well, you could do that, but what we're going to do here is choose a bundle and then choose the appropriate weights. So when we're thinking about risk and return, standard deviation is the most common measure of risk. This is the number we've been estimating since the first day of this course. So we can have an individual stock, and we can look at the standard deviation of that particular stock, or we can look at the standard deviation of a portfolio of stocks using that long formula that we saw earlier that includes the individual variances, the weights, and the covariances of all the individual components in the portfolio. So that standard deviation depends on all of the correlations and the weight that we give each stock. So we can manipulate the weights. We have no control over the correlations. We have no control over the standard deviations, given we've already selected the stocks. Now we can choose stocks that are highly correlated, weakly correlated, high standard deviations, low standard deviations. We can do that. But once we've selected those stocks, we have no control over how those stocks are correlated. All we can do is control how we weight those stocks. So the return is just the weighted average of the individual returns. So if we have a 3% return, a 5% return, a negative 2% return, we weight those values using the shares of the portfolio of the stock in the portfolio, and that's how we determine the return. But this is what we have to agree on right here. Before we can move forward and before anything else is going to make sense, we have to assume that for a given level of risk, we want the highest return possible. And for a given return, we want the lowest level of risk. So if we hold risk constant, we want the highest return. If we hold the return constant, we want the lowest risk. So if we only have two stocks in a portfolio, we can visualize this very easily and see the minimum variance here. So what we're going to do is vary those weights for each stock in the portfolio to see how the standard deviation of the portfolio changes. So we have two stocks here. Stock 1 has a return of 5%, a standard deviation of 10%. Stock 2 has a return of 6% and a standard deviation of 13%. And we are assuming the correlation between stock 1 and 2 is 0.4. So the only thing we can control from at this point is how much of the weight we put in one stock versus the other. So there are 3 points that are relevant on this plot. This point right here, it's not a point, but if we look at the top left, this has share of stock 1 equal to 0, which means everything is in stock 2. And notice we get a standard deviation of 13%, which is exactly equal to the standard deviation of stock 2. So if we're all the way over here with nothing in stock 1, we get the stock 2 standard deviation, and this portfolio right here would give us a return of 6%. On the far right, if 100% of our portfolio is in stock 1, so share of stock 1 is 100% or 1, we get a 10% standard deviation, which is exactly what we get right here. So this portfolio right here has a standard deviation of 13% and a return of 6%. This one has a standard deviation of 10%, a return of 5%. And as we vary the weight or the share of stock 1, as we go from 0 stock 1 to 100, our return is going to move somewhere between 5 and 6%. So as we move to the right, our return is going to move closer to 6%. But notice our standard deviation gets lower and lower and lower and lower and right here it's below 10%. And 10% is important because that's the least risky stock in the portfolio. So if we keep searching along this line right here, we get to this red dot where the share of stock 1 is about 70%. So at this red dot right here, we have 70% in stock 1, 30% in stock 2, and notice the standard deviation is somewhere, so this is going to be 10, 11, 9, somewhere above 9%, somewhere below 9.5%. And that's important because we have combined stock 1 and stock 2 in a way that actually is right here, 9.28. We have combined stock 1 and stock 2 in a way that we get a standard deviation in our portfolio that's lower than the least risky thing in the portfolio. And that's the beauty of diversifying or building portfolios, is we can do it to mitigate risk, or we can't eliminate risk, but we can minimize our risk by building a portfolio appropriately. So this is what we call the minimum variance portfolio. That's the portfolio or the combination of stock 1 and stock 2 that give the lowest possible standard deviation. Now, this next plot is going to show us what happens as we increase that correlation. So if we increase the correlation to 0.8, notice we never really benefit from diversifying or from building the portfolio, because we get a standard deviation of 13 if we're here. That's the same no matter what the correlation is. We get 10% right here. That doesn't depend on the correlation because we only have one stock. But notice when that correlation is high enough, the portfolio standard deviation never drops below 10%. We never do better than the standard deviation on stock 1 by if the correlation is too high. So if our correlation is too high, we don't really get any risk-reducing benefits of from combining stock 1 and stock 2 in a portfolio. So as we vary that correlation, we're going to see lower and lower amounts of the lower standard deviation in the portfolio. So if we're thinking about the minimum variance portfolio, all we're doing here is flipping it on its axis, flipping the axis over. So notice we have standard deviation on the x-axis right here, where we had it on the horizontal axis right here. So if you just rotate this 90 degrees, this little check mark right here, actually this one is easier to see here, this little check mark just gets, or this kind of check shape just gets flipped around. So what we end up getting right here is our minimum variance portfolio, but now we're looking at the standard deviation of the portfolio on the x-axis and the return on the horizontal axis. So on the other plot, we had the weight or the share of stock 1. Now we have the standard deviation of the portfolio and the portfolio return on that vertical axis. So this would be that point where we had everything in stock 1. This would be the point where we had everything in stock 2. And now we're seeing the different combinations of stock 1 and 2 still represented by individual points on this line. So if we want to look at efficient portfolios, so when we're thinking about efficient portfolios, which portfolios can we ignore? So which combinations of stock 1 and stock 2 should we ignore if our objective is to minimize the level of risk in the portfolio? So notice our minimum variance portfolio right here is this red dot. And everything below that red dot gives us a lower return. So as we move down, so we're coming down here, our return's actually getting lower. But notice our standard deviation is actually getting higher. As we move down and to the right, so as we're moving down this and to the right, our return's getting lower, our standard deviation is getting higher, and that is clearly not optimal. So if our objective is to choose the highest return for a given level of risk, I can get the same level of risk of 10% by choosing this point right here. So this point right here where these two lines intersect, they have a standard deviation of 10%, But up here, I'm getting a return that's greater than 5.5%. Down here, I'm getting a return of 5%. So why would I invest and get a lower return if I'm not getting any benefits of risk reduction? So this red dot right here represents the lower bound on our efficient frontier. So this minimum variance portfolio should be the worst you ever do in terms of risk return trade-off. If you go back and look at the plot this way, we're benefiting everywhere up into this red dot, because once we get down here to this red dot, our standard deviation actually starts to go up. So our standard deviation is actually increasing here, but as we move further and further to the right, more in stock 1, notice we're actually getting a lower return. So our return's actually getting lower as we move to the right because we're getting more and more in stock 1. So as you pass that minimum variance portfolio point, your return's going down and your risk is going up. And that is not the direction that we want to go. So any efficient frontier is going to be, any efficient portfolio is going to be somewhere on this red dot or above. So we can eliminate all the combinations of stock 1 and stock 2 that fall down here below this minimum variance portfolio point. Now, which point you choose depends on a lot of things. Depends on the individual investor. Apologize for that. I'm still battling a little cold here. Which point you choose on the portfolio, on that curve, depends on the risk-free return that we'll see later, and then the risk tolerance of the investor. But we can eliminate all of these here because they're lower return and higher risk. So we can do it again with high correlation. And notice we're not really benefiting at all here. So what we really want is a portfolio standard deviation that's less than 10%, because that's, if we're okay with 10%, we just put everything in the stock that has the 10% standard deviation. But that's not what we want. We want to do better than that. So if a correlation is too high, we never really get that risk-reducing benefit of building a portfolio. So we're on this blue line instead of the red one. So we like that low correlation or even negative correlation because it allows us to benefit in terms of the risk reduction. So we can do the same thing with 3 stocks. So it's a little more, not really more work because we're going to do it in Excel. But what if we want to do the minimum variance portfolio for A, B, and C? Well, we can't visualize it on a 2-dimensional plot like we did before as nicely. But we have stock A with a 5% return, 10% standard deviation. Stock B, 6%, 13% standard deviation. Those are the same 2 we had before. Then now we're going to add this third one with a return of 5.5% and a standard deviation of 8%. So notice A, B, and C, the return's going up. The return's going, as the return goes up, the standard deviation goes up too. This one should be kind of in the middle of those two, but higher return, higher standard deviation. We have to try all the different combinations of those 3 stocks and find the expected return and standard deviations. And there are an infinite number of combinations of stock A, B, and C. There are technically an infinite number of combinations between just A and B, but we can write the weights as WA 1 minus WA, because WB is just 1 minus WA, and it's easier to plot, it's easier to work with. But here we have an infinite number of combinations that are a little bit harder to work with. So we still find the return the same way. The average, the weight times the return, weight times the return, weight times the return. The variance, same formula that we had before. We have the weight squared variances. And then we have plus all these covariance terms right here. And then we take the square root of that to get, the square root of that to get your standard deviation. And this is what it looks like if you plot, I think this was 10,000 simulations. I think I simulated this 10,000 times. Let me actually double check. I'm not going to walk you through all the math here, but I'll briefly walk you through how I generated this. So I did this in R. Well, making these kind of plots in Stata, so it would be a nightmare. But all I'm doing here is setting up my three stock portfolio. Here, these are just the weights. So what we already have up here, so here I'm setting my returns and standard deviations. I'm setting my correlations. A typo right there. Let me fix that. I'm calculating the standard deviations the same way we would do it with the formula. I'm just doing the standard deviations and all of that, and the covariances that I set. But here's the three stock portfolio. Again, just setting my return, setting my standard deviation, setting my correlations. And what I did up here, I just simulated 25,000 portfolios. So I have 25,000 portfolios, so just random numbers. I make sure my weights add up to 1 by dividing by the sum. So if you take the weight and divide by the sum of the weights for all three, your weights will add up to 1. And all I'm doing for each one of those 25,000 combinations, I'm just finding the standard deviation of the portfolio. But I'm doing this 25,000 times, and I set that up here with this random number generator. So relatively straightforward, and then I'm just plotting this. And when you do all of that, you end up getting this plot right here, which is all the different combinations. These are 25,000 different combinations of stock A, B, and C. And notice the overall general shape is very similar. It's still this little inverted check symbol, except now we have another edge of it down here. But the same thing is true for the three stock case as the two stock case. For any standard deviation, we want the highest return. So if we take any point, just pick this random point, if there's one above it, then it's dominated. If there's one above that, it's dominated. One above that, it's dominated. So we end up all the way up here on this upper bound of this frontier where we have the highest return for every given standard deviation. And this is your minimum variance portfolio. So it's the same setup that we had before. Choose the weights to give us the highest possible return for a given level of risk. And here we can see the three individual stocks. So the red dots represent individual stocks. The black dots represent the combinations of those three stocks. And then that blue dot represents the minimum variance portfolio. So if our objective is to choose stock A, B, and C to minimize the standard deviation of a portfolio, we put 29% in stock A, 7% in stock B, and 64% in stock C. And then using those weights, the 0.29, 0.07, 0.64, we could go back and find the return of the portfolio using this formula right here. Just using the weight for A, the return for A, the weight for B, return for B, weight for C, return for C, and we could find out the return for this portfolio. And it's going to be somewhere somewhere between 5.5 and 5.25%. So that's how we would find the actual return for that blue dot. But the overall idea is simple. Given you have 3 choices, or 4 choices, or 10 choices, what's the appropriate combination of those choices to give me the least amount of risk possible? And we'll see later that the minimum variance portfolio is never going to be the optimal portfolio for an investor, but it's the starting point of our efficient frontier. So once we identify that point, we know that that's the worst we should be able to do. Because anything starting there and up and to the right, we now have a decision to make on the risk-reward trade-off. We can get a higher return, but we have to take on more risk. But once you know that minimum variance portfolio, you're never going to go below that, because going below that means you're getting a lower return and a higher risk, which is clearly not optimal. And we'll work through all of this in Excel. We'll do the minimum variance portfolio stuff in Excel because it's way too messy to do by hand. And I think it'll clear up a lot of stuff too when we start working with this in Excel.